Hello everyone. In this video, we'll be doing one problem related to combination of dielectric slab. In the previous video, we have studied about it. Okay. Yes. Here, it's given somewhat like this. Slab is inserted here. This is d by 2, d by 2. This is AR. This a slab having dielectric constant. Okay. You need to find equivalent capacitance. So this point is A, B, between A and A. So we'll convert it into our circuit, capacitor circuit. Okay. So this will be connected somewhat like this. Right. This C1, C2, C3. Okay. C1, C2 means this air and this dielectric constant K, and C3 is this one. Okay. Now C1, C2 are in parallel. So their equivalent will be C1 plus C2. That means epsilon naught A by 2 upon D by 2 for the air we are converting, and for the slab it will be K into epsilon naught A by 2 upon D by 2, since area and this length both are divided, right? So 2 cancels out here also. So this equivalent becomes epsilon naught A by D, in bracket it will be 1 plus K. Okay. Now the circuit, if you say modified circuit, will be somewhat like this. This is C3 and this is the equivalent 1. Okay, and this is point B and this is point A. Now we need to find it. So equivalent capacitance between A and B will be C3 into C equivalent 1 upon C3 plus C equivalent 1. That means it will be C3. C3 is what? It is epsilon naught A into K upon D by 2. So 2 will come upward and D will be downward. Multiplied by C equivalent 1 was epsilon naught A by D 1 plus K upon 2K epsilon naught A by D plus epsilon naught A by D 1 plus K, right? On solving this, you will get 2K will be 1 plus K upon 1 plus 3K into epsilon naught A by. This will be your equivalent capacitance between A and B. Okay. So this was one of the problem. Okay. Practice more like these. Okay. At your home. Now, our today's topic will be dielectric strength. Right. Dielectric strength. Firstly, we'll define what is dielectric strength. Okay. You can say that the maximum, this dielectric strength can be defined as maximum electric field that a dielectric medium can withstand. Dielectric medium can withstand without breaking down its insulating property. Okay. This is your dielectric strength. Okay, of a medium, you can say, right? and the potential difference at which, one more point, potential difference at which electric breakdown of dielectric takes place, that is called breakdown potential, okay, breakdown voltage, okay. The potential difference at which electric breakdown of dielectric takes place, that is known as breakdown voltage, okay. This will be more clear to you. We'll be solving problems related to this, okay. And this dielectric, one more thing, this dielectric strength that is calculated by, okay, can be calculated by dividing the breakdown voltage to thickness of the sample, means breakdown voltage upon thickness, means breakdown voltage of the material, okay, divided by the thickness. So the unit of this dielectric strength will be volt per meter, okay, or V by m, okay. uh, One more thing, that why we measure dielectric strength of any dielectric, okay. We do this, means the purpose of dielectric strength is to reach the point of breakdown, or you can say the failure, okay, means to reach the breakdown voltage, okay. And this happens when material experiences a sudden change in its resistance to the test voltage, okay, and the level of voltage where the barrier allows the current to flow in the dielectric strength of the material, okay. So this was basic intro about the dielectric strength, okay. We'll be doing problems related to this, okay. uh, we'll see one problem. If, see, there's a capacitor C1 of 1 microfarad, okay, and this can withstand maximum voltage 6 volt, okay. And there is another capacitor C2, its capacitance is given as 2 microfarad, and this can withstand maximum voltage 4 volt, right. So the question has asked you, what maximum voltage will the system of these two capacitors withstand, okay. Let me write it. What maximum voltage will the system of withstand if there are two cases connected in series another parallel, okay. So first case will be when they are connected in series. Let's say they are connected in series, okay. C1 is given as 1 microfarad, right, and this is given as 2 microfarad, okay. The potential V1 is actually 6 kilovolt, okay. Sorry, this is actually 6 kilovolt, okay. So the charge on this will be, in the first case, okay, the charge will be C1 into V1, that means Q1 equal to 6000 microcoulomb, and the charge which will be there on C1, there will be a same charge on the C2, right, because they are connected in series, right. And if let's say point A, point B, let's say this is VAB map, right. Now uh, by the uh, by the formula, if you calculate Q2, it is coming out to be C2 V2. The Q1 has come C1 V1, that means 6000 microcoulomb, and by this Q2 will be 8000 microcoulomb. Now see why I'm saying this, the charge on Q2 will be C2 will be 6000, sorry, 6000 microcoulomb, okay, because in series charge on each capacitor must be same, okay, as the maximum charge on C1 is 6000 microcoulomb, okay, which is minimum of the charge on C1 and C2, means the charge on this, okay, is the maximum charge on Q1 is, oh sorry, maximum charge on C1 is 6000 microcoulomb, okay, which is the minimum of charges on both capacitors, okay, and the maximum charge on this is 8000 microcoulomb, which is actually not what, if you say that why we have taken 6000 microcoulomb, let's say if we take 8000 microcoulomb and give it 8000, then 8000 microcoulomb, then we also need to give this 8000 microcoulomb, but it cannot be withstand that amount of charge, okay. That is why the charge on the second one 2 microfarad capacitor will also possess charge 6000 microcoulomb. So by this VAB max will be V1 plus V2. That means we have got 6 kilovolt plus 3 kilovolt. How we have got 3 kilovolt? 9 kilovolt. Because the charge on this one 6000 microcoulomb and its capacitance is, I think its capacitance is 2 microfarad. On dividing this, we'll get V is equals to 3 kilovolt. We already knew that potential difference across C1 is 6 kilovolt. Okay, we need to calculate it along this C2, and we have got it 3 kilovolt. Now the second case, when parallelly connected. Now in parallel, let's say in parallel, your that should be same potential. Okay, so the second one means this can withstand maximum potential 4 kilovolt. So the potential difference across C1 must not be greater than 4. That means both will possess potential difference of 4 kilovolt. This is very simple. Okay, and VAB max will be maximum minimum of both ones, that is 4 kilo. You've got in case 1 you've got VAB max 9 kilovolt, and in case 2 you've got VAB max equal to 4 kilovolt. So this was a basic problem. Okay, now we are done with our first part of capacitor. From next video I'll be studying transient current and growth and decay of charge. Okay, I think one more topic is left, that fringing electric field one. So I'll be covering that one the last. Okay, thank you.